Hi, everyone. As you know, I'm Sommer Panage, and I am so excited to be here at UIKonf. I currently work at a small fitness startup in San Francisco, California, called Chorus Fitness. Before that, I was at Twitter and Apple and in the circus for a bit. I'm really excited to talk to you today about something that I care so much about, and that is accessibility. We're going to take a look at this topic from 3 different angles. First, I want to explore what it means to be a user of accessibility, particularly on Apple products. Next, I want to dive in to talk about what it means to be designing an accessible product. And finally, we'll look at accessibility from a development standpoint, looking at the UI accessibility protocol. So without further ado, let's get started. First, we're going to talk about users. When users think about accessibility, what is it they're dealing with? Well, what they're doing is they're using technology to overcome challenges. When we talk about the users of accessibility, we refer to people who are accessing our content via assistive technologies. Generally, we, as developers or product creators, provide the content, while other companies, such as Apple or Microsoft, provide the assistive technologies, via which this content is transformed or accessed. Before we talk about Apple's assistive technologies explicitly, it's important to understand that assistive technology is not just for the blind or the deaf, etc., but we actually all benefit from assistive technology, and you're looking at a few of them on the screen right now. Assistive tech isn't just for others. A large portion of us in this audience are using assistive technology right now with our glasses or my contacts. If you've broken a leg or an arm, you've used crutches or a sling, all of these things are assistive technologies. So this isn't something for someone else. This is something we're all very familiar with. But of course, there are specific technologies that are built into our devices that we really want to focus on today. An exact definition of assistive technology is any item, any piece of equipment or product system that can be used to increase, maintain, or improve the functional capabilities of a person with a disability. And I crossed out with a disability because that sometimes has a connotation of otherness. But in reality, we can all have a disability at any moment, even if it's nothing more than the glare, hitting our phone and not being able to see it the way we normally do. So now that we know what an assistive technology is, what are the assistive technologies that users of iOS devices are interacting with? We can break down these assistive technologies by their function. So let's start with vision. What helps with vision? Well, it's important to know, first of all, with vision, that it's a very big category. 285 million people are estimated to be visually impaired. That's about 4% of all people in the world. And of that, 14% of those are completely blind. Also, beyond blindness, we want to consider other visual challenges, things like color blindness or glaucoma, or of only having one eye, for example. So the most well-known assistive technology for the visually impaired is arguably VoiceOver on iOS. VoiceOver is Apple's screen reader, and it's available on all the iOS devices, on the watch, on the Mac. It reads out the text on the screen via either audio output or via Braille output. It's incredibly feature-rich. In fact, I could spend this entire talk just talking about accessibility features of VoiceOver alone, and I don't think I would get through them all. It's really powerful, and I highly recommend you go into your phone and just start playing with it. It's incredible. But instead of spending the talk on it, I just want you to see someone using it, because that is actually the most important part. So I'd like you to meet Tommy Edison. He's been blind since birth, and here we can watch him interact with a pretty old version of iOS using VoiceOver.
Today I want to show you how the iPhone works. A lot of you guys have been asking, I see you using an iPhone, but how does it work for you? Well, I'm going to show you. So a lot of devices have this thing that you probably never even thought to use or check out or anything. It's called accessibility.
Accessibility button.
That'll show you all different sorts of things, how to turn a speech on and off of your phone to white on black, black and white, maybe mono audio. There's all sorts of different things to do. So I just use the VoiceOver one and it works incredible.
VoiceOver on button.
But it's a very cool thing and it allows me to use something that has a touch screen
104.
just like you do.
Slide or double tap.
So each thing,
Double tap to open.
touch it once, it tells you what it is, twice to perform the action.
Notes. Maps. Stocks. YouTube.
And then to move to the different screens, 3 fingers to go left like this.
Page 2 of 4. Game Center.
So let me show you how some of this stuff works.
Twitter. Double tap to open.
So let's. All right, so let's see what's going on in the Twitter universe today.
Chris Moyles. For those watching Love Machine, the girl next to me is actually 8 foot tall, which is why I look short.
Why don't I tweet something?
New tweet. Button. Text field. Is editing.
All right, so when I tweet, I generally cheat and use Siri. It's easier that way.
Dictate.
Happy Easter, comma, from the blind film critic.
Happy Easter. From the blind film critic.
See, pretty innocuous, nice little tweet. So let's put it up.
Tweet. Button.
One of the things I don't think people get is when you talk to Siri, if you add the punctuation yourself, it works so well.
All right. So VoiceOver is just one feature that you, as a developer, can support to make users like Tommy's experiences so much better when they're using your application. For low vision users, there's a quick and easy zoom feature. With just a 3-finger double tap, you can zoom the screen for a close-up of whatever's there, and you can pan around and look at it. Now, this is a feature that comes for free for developers, meaning you don't actually have to do anything in your application to support it beyond, of course, having good high-resolution imagery. Magnifier is new in iOS 10. This allows you to use the high-resolution camera of your phone to increase the size of anything you point it at. For those with color blindness or other disorders which affect color or light perception, there's a whole host of display accommodations, such as color inversion, color filters, black and white mode, etc. And while these features are free for developers, meaning you don't really need to do anything to benefit from them, you do want to be sure that you're making good choices with your colors and with your fonts in order for them to play well with these types of adjustments. And we'll talk about that more in the second part of the talk. Additionally, low vision users can increase their system font significantly. Here you can see the modification in the accessibility settings in my iPhone. And we can see also how it impacts one of the Apple apps, Messages. As a developer, you can support this by always using dynamic type in your applications, and we'll look at that a bit more later as well. So now let's touch on assistive technology that focuses on users with trouble with hearing. Hearing loss is another big category. 360 million people are estimated to have hearing loss worldwide. That's about 5% of people. For users with hearing loss, standard features often act as assistive technologies. FaceTime has provided an amazing tool for the lip reading and signing communities, while iMessages and SMS in general have become a primary communication tool for many with low hearing. Beyond that, AV Foundation supports captioning and subtitles, making it easier for hearing-impaired users to consume content. There's also special made-for-iPhone hearing aids and TTY support. As a developer, most of these technologies for hearing work seamlessly with your apps. And provided you give captions to any video or audio, you're essentially set. However, there are some design considerations when it comes to how we use sound in applications that we will discuss shortly in the next section. Next, there are motor disabilities. In the USA, about 18 million people, or 7% of adults, have difficulty walking a quarter mile. Motor disabilities can be caused by many things. They can be temporary incapacitations, if I break my hand, or they can be chronic conditions caused by cerebral palsy, muscular dystrophy, or multiple sclerosis. For those with little or no motor ability, there's something called switch control. Switch control works by scanning your screen and allowing you to interact with it with as little as a single button. These buttons are called switches, and they can be controlled via an actual button, via tapping it, via gestures, breath, eye movements. Many things can control these switches for those who don't have any other way to interact with their screens. Rather than me describing it, though, because it's a bit hard to imagine, I'd like you to meet Christopher, and he's going to demonstrate how switch systems allow him to create movies.
Christopher? I think there might be a slight problem.
What?
Well, you can't exactly touch the screen.
Just as the It's kind of extreme. Not worrying out to access isn't an expression anymore.
The foundation of everything Christopher does is an accessibility feature called switch control, built into Apple devices.
Har all Christopher via eligible in Israel.
Christopher says, with switch control, I am still limited. But it's no longer my body that limits me, it is only my imagination.
The really important thing to notice here is what it says at the very bottom of the screen. This video was made by Christopher, and you can find many more like them on YouTube. He does all of this with essentially a single button and a cursor scanning his screen, and it's incredible. For those with a bit more motor control than perhaps Christopher has, there are other features as well. There's something called assistive touch that I bet many of us are familiar with if we ever broke our home button. Yeah, I know. So what assistive touch does is it takes hardware buttons and it takes multi-finger gestures and it allows you to interact with them with a single tap, because sometimes that's maybe all you have available to you. Again, another case of standard features actually becoming assistive technologies happens with motor impairments. Siri and dictation are heavily used features. As the speech and Siri APIs are developing, it can be really beneficial as developers to consider integrating them into your applications. And I have a feeling that those APIs are going to keep growing, and there's going to be more and more opportunities to bring those into our apps. One more area of disability is learning and cognitive. In the USA, 7 to 8 million people of all ages have some form of cognitive impairment. And additionally, there are milder forms of cognitive challenges that aren't even accounted for in this number, like ADHD. Guided access is one feature that Apple provides to help people with autism or other attention or sensory challenges to stay focused on the task at hand. With guided access, a parent, a teacher, or a therapist can limit an iOS device to stay in one app by disabling the home button and even limiting the amount of time spent in the app. Other standard iOS features have become assistive technologies for people with learning disabilities as well, such as the dictionary and text-to-speech. So now that we've gotten a better understanding of the types of users that might be using accessibility and what those assistive technologies may be, it's important to take a look at our application's design and how that interacts with these technologies. As iOS developers, we are frequently our own designers. Unless you're working for a company with a design team or a dedicated designer, you often are in charge of your own fonts, your own colors, and your own layouts. What is more, even if you do have a design team, it's always good as a developer to have a keen eye for accessibility considerations because perhaps it was just something they didn't get a chance to think about. The thing about accessible design that is often overlooked is that it does not just benefit those with some form of disability. It benefits everyone. And I've always felt like this comic explains that really well. We see a group of students waiting to get into a school, there's a ramp, and there are stairs. And we see that if we shovel the stairs, most of the students can get in. But if we shovel the ramp, all of the students can get in. And that, to me, is kind of the essence of what we're saying with designing something accessibly. Because accessible design is good design. It benefits people who don't have disabilities as well as people who do. It's about removing barriers and providing the benefits of technology to everyone. This is something that Steve Ballmer says, and it continues to ring true. So now let's look at some specific examples of what it means to design for accessibility. And we're going to start with VoiceOver because that's one of the biggest technologies we end up thinking about when we're doing accessible design. So when you're building your app, every time you create a button or you use an image that the user can interact with, or that provides information, you want to make sure to also document what labels and values for that image or for that button might be. You want to capture not just what the button does. So in this example, we have a play button. That seems like a great name, play button. But we also want to capture the state. So for example, here in Spotify, I can shuffle my tracks, and that button isn't just a button, it actually maintains state. So I would want to say something like shuffle tracks, on button. And then the user can know, oh, shuffle tracks is on. If they tap it again, it will turn off. And sometimes that copy can become quite verbose, but that's okay if that's what's really required to understand what something does. Here in Spotify, again, we see the Add to Collection button, and that's a bit more complex. Add to Collection button. Track is not in your collection. So we're providing all that information about not just what something does, but about its state to the user. With every button and image, it's important to ask yourself, what does this do? And what are the different states, and how can I describe those clearly and succinctly to the user? So this is, when you're designing the application, it's important to think about those questions as each kind of button comes into place on the screen. Now, another thing was when you're designing an app, you think about navigation. And it can be really exciting to think about making a whole new navigation style that no one has thought of before, with things over here and there and swipey swipe. And that's exciting. But don't do this. When it comes to navigation, VoiceOver works best with the standard stuff that we know and we love. So don't reinvent the wheel. What does it work best with? It works best with tab bars. It works best with navigation bars. It plays well with hierarchy. So what shouldn't you do? Try not to make up your own new thing. Not only will this not necessarily play well with VoiceOver or with switch systems or anything that puts a cursor on the screen, but it actually can confuse users who aren't using those technologies at all. Not everyone is a power user. Not everyone is on their device all the time like we probably are. If any of you are Visco users, you might remember the joystick redesign. It seemed like a cool idea. It looked like this, and you kind of moved it around like a joystick, but it was a touch thing. Perhaps it was cool, but was it accessible? No. So try to avoid doing these things if you can help it. Along the same vein, we want to favor simplicity. Often, when a user comes to your app, especially if that user has VoiceOver on, he or she will navigate around the screen for a while, kind of figuring out the lay of the land. Where do things go? What do they do? And you don't want to make that process difficult. Imagine having to go over this screen with a screen reader. It would take a day. So when in doubt, you want to favor navigation as opposed to putting more content on the same screen. It can often be much easier for a user to go to another screen to learn a bit more than to have to do all of it on the same screen. We don't want to overload each screen with a million functionalities. There's a few other things to consider with VoiceOver. We want to make sure that text is text and images are images. Having images that are text is something that you want to try to avoid. We want to support standard gestures. So as you saw when Tommy was using his device, he had some gestures that he was using, and we want to make sure we're always supporting those. We want to avoid things that are super discoverable because oftentimes they're just not going to get discovered at all. Interactions should be obvious. And one of the most important things I like to tell people is you're designing an experience for your VoiceOver user, not just putting labels on buttons. What does that mean? Well, when I think about experiences, I think about a tweet. I think this is a really great example. Now, when I consume a tweet, I can see it. And I don't see profile picture, text, oh, there's a favorite button, there's a timestamp. That's not how I see a tweet. I see a tweet. It's just one thing for me. But if I just focus on labeling it and I don't think about that experience, then I'm going to get an object with 7 labels at least. And now if you think of a Twitter timeline, I'm going to have a bunch of those on a screen. And imagine trying to navigate that with a screen reader. It's not even going to be obvious if the favorite button goes with the tweet below it or above it. It's not super clear. So what I want to think about doing is instead of just labeling everything and making it technically accessible, which this was, I want to think about making it as similar as I can to the experience of my sighted users. So what we did when I was at Twitter is we synthesized all the information in a tweet into one label so that a user could consume one tweet with one VoiceOver message. And so we concatenated everything together. We elongated the timestamp to make more sense, 44 minutes ago. And then at the very end, we provided more information telling the user how they could interact with the tweet rather than hydrating each individual button on the timeline, which would get very excessive very quickly. So this is one example about thinking about creating equal experiences rather than just slapping labels onto everything. So that's what I like to think about with VoiceOver, kind of the big concepts. But there's also things to think about with visual design when the screen reader isn't even running. Probably the most important is dynamic type. Considering your font, you want to have your font sizes not be absolute. This is going to benefit you in multiple ways. One, if my font sizes aren't absolute, I can crank up that font size that we saw earlier, and my app will accommodate it. And also, if I know that as a designer, if I know my font sizes aren't absolute, then I'm going to design a more flexible interface to begin with. So we saw dynamic type earlier. Dynamic type automatically adjusts the tracking and leading of every font size. And there are 10 different text styles that dynamic type supports. So if I'm a developer and I want to support dynamic type, this is essentially the code I'm going to need to write. So it's very simple. You're going to need to request a preferred font for a text style. So rather than saying font for size, I'm going to get a preferred font for a style. For any UI label or text view or text field, I also can set the adjust font for content size category to true. And what that means is that if the user goes to setting, changes their font, when they come back to my app, I'm going to have a notification and everything will already have updated for me. And the last thing is if I still want to actually update my interface even more, I can subscribe to a notification that tells me when font size has changed. So if we look at this code, we see the first thing already, adjusting the font for the size category, and here we see the notification. There it is. So those are the 3 steps you can take, and the third one is optional. You may not even need that notification to support dynamic type, and that's it. Then your fonts will grow and shrink as you hope. Another important consideration for visually designing your app is foreground versus background. Between foreground and background, you can always calculate a contrast ratio. And for low vision users, that contrast ratio is very important, because if it's too low, they can't really read it. We can see an example here. At a 2.0 contrast ratio, we have a gray on gray, and it's not super easy to see. Now, if we just take that gray on top and we make it a bit darker, almost to a black, all of a sudden we bump our contrast ratio to 10.9, and that text is much more visible. At the very bottom, you can see a link, and these slides will be published, and you'll be able to get that link, but that's a link to one such site that will calculate your contrast ratios for you. So every time you're designing something with text on a background, you want to go and check, is that contrast ratio high? How high? Well, if the text is big, we want at least 3 to 1. And if the text is small, we want to go for at least 4.5 to 1. And generally, the threshold for a big is around 18. So there we go. Something else that's really important to think about with accessibility is how do we convey information to our users, especially when that information is important and it's a subtle state change maybe in our UI. So here's my really simple password page, and the user enters her name and her password, and so far so good, but my password is wrong. So I see this. That seems obvious, right? It's red, it must be wrong. But if I don't have standard color vision, if I can't see red, all of a sudden, it looks like this. Well, what's wrong? Did it time out? Does this app not work? Should I just delete it from my phone? What's going on here? So which field was wrong? Well, it was password. How can I indicate that more clearly? A couple things. First of all, visually, I want to use more than just color to indicate the password was wrong. I actually want to add some text that explains what's going on. And that can all still be in red, because my sighted users will appreciate it. But now, even if I don't have full color vision, I can see, oh, password is incorrect. I'm good. Very similarly, had this been sound, the same thing applies. We never want to indicate something with only sound or only color. We always want to use at least a couple different ways to communicate important information. And finally, you'll see this little speech bubble. If my user has VoiceOver on, it would be great if we could announce to them exactly what went wrong. So, hey, password is incorrect. And all of a sudden now, we have something that is a much better experience, just by keeping in mind these key ideas. A few other visual considerations before we move on. Tap targets, that's always a big thing. Don't let them be too small. Sometimes it can be fun to have those little tiny things to tap on, but if it's smaller than 44 by 44, it's going to be really hard to touch. We already talked about simplicity. I'm going to say it again. Keep the color scheme simple. The fewer colors you have contrasting against each other, the more likely things will be very easy to take in, to view. And also for people who might have attentional challenges, really crazy color schemes can be overwhelming. And again, always I will repeat this, avoid clutter. Avoid clutter. Favor simplicity. So now that we've taken a look at many of the visual considerations in accessible app design, let's drop one level lower and let's think about this as developers, and let's get into a little bit of code. In this section, I'm once again going to focus on VoiceOver support, because by supporting VoiceOver at the code level, we often will get switch system support as well. So we kind of covered two major areas of accessibility support. So to develop with accessibility in mind, there are two key steps. First, you need to be able to audit your application for accessibility. That means you need to go through your application and identify any issues, buttons without labels, gestures that don't work. Next, you need to be familiar with Apple's accessibility APIs so that once you find those issues, you can go fix them. So let's take a look at step one, the audit. The best way to audit an application is to turn on VoiceOver or a switch system and go through your app. There is an accessibility inspector, which many of you may have already seen, and this is one way to take a look at accessibility, but the best way is always going to be through experience, especially if you want to really challenge yourself. Close your eyes and see how far you can get without even being able to see a thing. So I'm going to show a couple examples of some app audits. We're going to look at Spotify first. Spotify fared pretty well the last time I went through and audited it. So let's take a look at what a good grade looks like.
Spotify, main menu, your library, heading, playlists, stations, songs. Discover weekly, playlist bullet, back button. Available back, shuffle play, button. Available offline, switch button, on. Double tap to, running for cover, Ivan and Dalia, running for cover, Ivan and Alyosha bullet all the point are have, please, running for cover bullet Ivan and Alyosha.
If I could wake my crooked heart.
Running for cover bullet close, button. Q, button. Playing from playlist. Discover weekly. Collection. Track is not in your collection, button. Double tap to add track, running for cover.
To miss the mark.
Track position. 35 seconds of 3 minutes. 56 seconds. Adjustable. Swipe up or down with one finger to adjust the value. 1 minute. 37 seconds of 3 minutes. 56 second. Pause. Button.
Okay. So we can see Spotify did pretty well. Everything was labeled. The grouping of content overall made sense. There were a couple spots where maybe grouping could have been better. We were able to navigate. We were able to skip ahead in the track, pause and play, see our playlists. There was really never a moment where it wasn't clear exactly what was going on. So I'd say that Spotify did pretty darn well in that audit. Now let's see someone who didn't do so well. Before we all hate Medium, I want to point out this is a much older version of the app. They have done a great job at improving the application since I did this video, but nonetheless, it remains one of the best videos of what to do wrong. So let's see.
Medium. Double tap to open. Selected. Tab. 1 of 5. Tab. 2 of 5. Read top stories for you. Small X. Button. Read later. Button. Dismiss. Button. Recommended by one. My plan to defiltering ISIS. Hillary Clinton. The 1. 4. Tab. 3 of 5. Text field. Is editing. Character mode. Insertion point at start. Clear. Button. Next. Button. Drafts. Button. Close. Button. Editor toolbar title 0. button. Editor toolbar quote 0, button. Editor toolbar list 0, button. Close.
All right, so that was great, right? No, lots of things wrong. Tabs not labeled. VoiceOver could see items that weren't even there. Grouping of items was poor. Hillary Clinton was the author of what? I didn't even know. Yeah, the list goes on and on. Again, I do want to point out it's gotten much better, so Medium, we still love them. But they had to fix it. And how did they fix that mess? Well, code, that's how. So we've seen what some of these accessibility issues can look like. So now let's dive into the code just quickly and see how we can make them better. I want to point out, this is not meant to be a deep dive into Apple's accessibility APIs. I definitely need a much longer talk for that. This is really just to showcase a couple things. One, some basic principles, and two, I want you to actually see how easy it is. So in order to support accessible technology in iOS, we want to conform to the UI accessibility protocol with our views. Luckily, all UI views already conform to this protocol, which means, generally speaking, you're simply modifying a few values to get things to make more sense for your application. So how does UI accessibility work? When VoiceOver is running, it creates an accessibility tree of your UI. The system goes through everything that conforms to the accessibility protocol, and it asks three main questions. It says, who are you? What are you? And where are you? Now, how does that translate? Well, who are you means, what's your label? What do I say to say that you're on the screen? What are you translates to exactly what you said. What are you? Are you a link? Are you a button? Are you disabled? Are you a heading? Those are traits of the object. And lastly, where are you? That's the frame. We're all familiar with frames, layout subviews. It's that. So I have a quick little demo app we're going to look at. And this is just a simple thing that I whipped up. It is something for children learning their numbers or their colors in either English or Chinese. We can see it's quite simple. We tap the answer button. We see the answer. How many circles are there? We can jump to the next one. We can see what color is it. It's blue, or however you say that. I don't actually speak Chinese. And this is basically the whole app. It also has a review section where you can review everything that you've learned. So how are we going to make this app accessible? Well, we're going to look at the code and find out. So the first question is a what is this question. So let's see where my app fails at first.
Learn numbers. Learn colors. Learn shapes. Review.
So that doesn't seem that bad, but what's missing is that we don't really know we can tap these things. If we're new to the app, we get in here, I hear all this learn, but I don't hear anything about how I interact with it. The thing is, a tap plus navigation is generally button behavior, so even though these are cells, I want to treat them like buttons. How do I do that? UI accessibility traits. So UI accessibility traits answer the what something is and kind of the how of how it behaves. So common traits would be things like button, header, link, image, or adjustable. We saw adjustable in Spotify when it said you can swipe up or down to change where you are in the track. So now,
learn numbers, button. Learn colors, button. Learn shapes, button.
There we go. That's all I did. So how did I do that? Well, here's my standard cell code, and all I had to do was OR in the button trait to the cell's accessibility traits, which it already had. You'll notice I OR'd in the trait because, as I mentioned before, UIKit objects already support accessibility, and they already have traits associated to them that are default traits. And so we want to make sure we're just adding to that, not overriding something that's already there. The traits allow the system to manage this information, and it can communicate this information in a standard way so that different app developers aren't communicating what a button or a link is in different ways. Traits are already localized for you, so I don't have to worry about localizing words like link or button. And they have standard interaction patterns, so if someone can use something that's adjustable in Spotify, they can use something that's adjustable in my app. They also hook into VoiceOver navigation in the rotor system, which we'll see in just a second. So let's look at another failing in my little learning application.
How many circles are there? Union Jack. button. China flag, button. Next.
So what was the issue there? Well, Union Jack button and China flag button, they're almost right, but the problem is those don't really say what the buttons do. And why is that? Well, it's because they're just using the file name, because that's a default behavior. VoiceOver will just grab the resource name or the file name when it doesn't have an appropriate accessibility label to source. So the name should be short and clear. So we want to use the UI accessibility label to provide this information. And if we need to give a little more information, we want to use the UI accessibility hint as well.
English answer, button. Shows the answer in English. Chinese answer, button. Shows the answer in Chinese.
So that gave us both the label, English answer, button, and it gave us a little more information if we weren't clear what that button did. Now, you might be wondering, I don't think users needed that hint. And you might be right. But that's why hints are read after a pause. So users can skip them, and they can even turn them off at the system level. So generally, it's not a big deal if you add a little extra information into that hint. What does the code look like? Well, here's some make a button code in Swift. And I'm just going to add in my accessibility label and my accessibility hint. Now, there's one thing wrong here with this slide that I just did for simplicity. These aren't localized. Unlike traits, you do need to localize your strings for all things accessibility. Traits you get for free, but everything else you'll need to make sure to run through localization. A few more general things on labels and hints, as I mentioned, need to be localized, and the hint is optional. Labels should be really short and clear, and they should never contain trait info. The fact that those things said button, that came from the trait. And hints should always begin with a verb, because they are describing what is done. One more issue in my little app and a little bit more code.
China flag, cute. Got it, button, got it.
All right, you might not have known what exactly was wrong there, but that got it button, that's how I get back, right? That's how I got the thing to flip back and I go back to my lesson. But got it, not really an obvious way to do that, and not really standard. So VoiceOver supports default gestures for common behaviors. One of those common behaviors is going back. That gesture is a two-fingered Z gesture. There's some other standard gestures that are supported as well, but we want to focus on that Z gesture. So what I need to do in order to make it easy for the user to get back to the lesson is I should support that so they don't have to go find a button that doesn't even really make sense. So what does that look like?
English answer. Button. English and blue.
So this is the old way.
Button. Got it.
Tapping got it.
Colors. Chinese answer. Button. Chinese. Lan.
Two fingers. Supporting the Z gesture. So again, it's a little simple thing, but it makes a huge difference to your users who are expecting this gesture to work. This is automatically supported by navigation controller, but you need to implement it manually for anything modal, like we saw here. What does the code look like? Well, there's my answer view controller, and I simply need to add accessibility perform escape and tell it to do the exact same thing you do when you tap got it. Again, very simple. Every one of these examples was a couple lines of code. So these gestures and actions are going to help your VoiceOver users a lot. We want to avoid anything custom and really try to stick to these standards. And we can support more things as of iOS 8 with custom actions, which are something I really encourage you to look up if you want to have a little more customization power over what you can do when you interact. And finally, if you want to allow the user to navigate your app in a custom way, whether it's in this app maybe by colors or by shapes, I can support accessibility custom rotors, which I'll be posting a blog post on soon, so if you're interested in that, check it out. So that was our kind of quick tour through some of the code and how simple the code can be to make an application accessible. And that essentially concludes our tour of UI accessibility overall. So now that I've talked about accessibility for users, for designers, and for developers, I want to wrap up by encouraging all of you to think about being accessibility advocates. Because everyone can be an accessibility advocate. We all want the same things. Nobody wants a hard-to-use app. We don't want our apps to exclude certain people. A company wants more users. It wants more use. We measure DAUs, we measure MAUs, and we want these numbers to all go up. And they will go up if our application is easy to use and accessible. That said, I know that it can be easy to get stuck in the "it works for me, so it must work for everyone" cycle. So as you do your work, remember, not everyone is a power user. Everyone comes to your app from a different place with different needs. If you see a feature that might not work well for someone with a disability, or maybe just for someone who's colorblind, or for your little sister or little brother, say something. Talk to your designers, talk to your product manager, and say, this isn't good, this isn't accessible, and make a change. Sometimes I get questions about what happens if I want things to be accessible but management isn't into it? How can I convince them that this is something that's really important? So here's some things that have helped me over the years. Automation tools are generally based on accessibility, and you can think of accessibility as a way to attach meta information to your views. So it makes sense that accessibility helps you build automation. And this argument has often helped me convince management that there's more benefits to accessibility than just what we've already seen. Accessibility means more users in general, and it means often good PR for your company. Also, the accessibility space is wide open for innovation. So if you want to give your employees a chance to create and think of something new, this is a space that is just ready for that. And it's a great space to create something brand new that you can share with the world. And finally, accessibility is the right thing to do. People often ask me as well, if it's useful to get stats on users, will that help sell accessibility to management? Often these numbers can be more trouble than they're worth. For example, if we ask how many blind people use our app, and our app is completely not accessible, the answer is probably 0. And that number is not going to sell upper management necessarily on why I should make it accessible. But that's obviously a horrible reason and horrible logic for not doing accessibility. Additionally, there are some privacy concerns that have been voiced by the accessibility community when it comes to getting numbers about them and tracking them using assistive technologies in your application. So generally for me, I recommend using numbers just as a way to understand what's working in the app and what's not, but trying to not use them to push DAUs or to sell accessibility. In the end, I find that is best done by talking to real live users and understanding what they want and what they need and why it's important to them. In the end, accessibility is for everyone, and it benefits everyone. And absolutely everyone involved in technology can become an accessibility advocate. That concludes my talk. Sorry for running a little over, and thank you all so much.